High temperatures can cause a number of challenges on a production line, also when it comes to quality control. In this video, I will show you how we overcome these red-hot challenges with advanced machine vision. The production line on, for example, a steelwork is probably not the most comfortable place to hang out. So naturally, you want to automate quality control on that type of production. You can do that with machine vision, but the temperature of the items also becomes a challenge for automated quality control. Let's say you want to inspect red-hot steel slabs for surface defects. You would typically do this by projecting light onto the surface and looking for shadows. But the challenge is that a steel slab at around 800 to 1000 degrees Celsius emits light in the form of near-infrared light. In that case, you have to use filters that can remove light in the spectrum of near-infrared light. And then with the help of our own light source that projects white light, we can see the surface defects emerge. An alternative approach is to use 3D cameras to measure depth. However, the speed and vibrations of the passing steel makes it difficult to inspect though, as well as the scales growing onto the surface of the steel as the steel cools down. Sometimes, however, it can actually be an advantage that the hot object emits light. For example, in cases where you want to measure dimensions such as the length of a steel slab. In very hot production environments, it can be an advantage to place the camera far away from the line. We have cases where we have inspected a part at a distance of 25 meters using the light that the part itself emits in the form of heat. By applying a bandpass filter, which filters out all light at higher and lower frequencies than that emitted by the object itself, the object appears white in the image and thus the dimensions can be calculated. However, this is not a straightforward approach as the temperature defines how much light the object emits. So you need to know the temperature and compensate for any fluctuations. It's not only in extreme environments like a steelworks where heat can be a challenge. If you have a production environment where the temperature rises above 40 to 45 degrees Celsius, you need to think about how to protect your vision equipment so you don't reduce the lifetime of the system. Very hot objects generate radiant heat, which you need to protect your camera from. You can do this by placing a heat shield between the object and the camera with only a small hole for the camera to see through. To keep the temperature down, you need to circulate the air between the camera and the shield, which you can do with compressed air. However, this is not without complications as compressed air will rarely completely be clean. There will always be some small water or oil droplets in it which can settle on the camera and disturb the image, so you need to be aware of this. To protect the camera, you will often place it in a camera housing just like this. But the heat the camera emits in itself causes the temperature in the camera housing to rise, so you'll often have to cool down the camera housing. This can be done with compressed air or water cooling or a combination of both. So high temperatures create challenges in several ways. It can make it more difficult to take suitable pictures, and secondly, heat can damage your equipment. But with the right technique and precautions, you can still do automated quality control in red-hot production environments.